Continuing with our Chapter 1 Equations and Inequalities, we're going to look at Section 1.4, Radical Equations, Equations in Quadratic Form, and Factorable Equations. When the variable in an equation occurs in a radicand, the equation is called a radical equation. So if you have a variable under the radical, it could be square root, cube root, whatever. When the root is square root, we will find the principal square root. The principal square root of any non-negative real number is always non-negative. Now, why do they say non-negative and not just positive? Well, because 0 is included, and 0 doesn't get a sign. 0 isn't positive. So in order to say positives and 0, we just say non-negative. Okay, so we've got the steps laid out here for solving radical equations. You really have to follow these steps by the letter or you won't get the answer correctly, because we are going to use a technique that can introduce some issues, and we just have to, as long as we understand what's going on and we follow these steps, we'll be okay. And the very first step is to isolate the radical. So for the example we've been given, notice that here's the radical, square root of 8 minus 2x, but it is not by itself on one side. That's what we mean by isolate. Get it alone on one side of the equal sign. So we're going to have to add x to both sides so that we will have the radical isolated. Now the problem could have been presented with the radical already isolated, and we don't need step 1. But in this case, we do. So we'll add x to both sides and have the square root of 8 minus 2x is equal to x. We've completed step 1. The radical is isolated. Step 2, raise both sides of the equation to the power of the index. Remember what the index is. That's the root here. So when there's nothing written, of course, we know that's square root, or 2. But if it had been cube root, we'd have a 3, and we'd raise both sides to the 3rd power. If it had a 4, we'd raise both sides to the 4th power. But we know it's square root, so we'll raise both sides to the 2nd power. So the square root of 8 minus 2x squared and x squared. Okay, this is the little trick we're using to get the radical off of our variable so we can get the variable alone and find out what x is equal to. Okay, when you take the square root and square it, you just get back to what you have in your radicand. So we have 8 minus 2x here and x squared here. Now this is a quadratic equation because the highest power on x is 2. So let's get it in standard form. We'll either factor. That's probably what we'll do since it looks like a simple one if it's factorable, but you could also use the quadratic formula. I like my x squared, as I've said before, I like the coefficient to be positive, so I'm not going to subtract x squared. What I'm going to do is move everything over with the x squared so it stays positive. So I'm going to add 2x and subtract 8 so that I have 0 equals x squared plus 2x minus 8. Add 2x to both sides, subtract 8 from both sides. And indeed, this is factorable. X plus 4, x minus 2. If you FOIL that, you'll get x squared plus 2x minus 8. Using the zero product property, x plus 4 equals 0, and x minus 2 equals 0. If this times this is 0, then one of those has to be 0. X equals negative 4, and x equals 2. Now, typically we say, you can check it, but basically, unless you've made a mistake, these are your answers. Not true for a radical equation. Step 4 is necessary. You have to check every time. So let's check x equals negative 4. Back to the original equation, the square root of 8 minus 2 times negative 4 minus negative 4 equals 0. The square root of 8, negative 2 times negative 4 would be positive 8. Minus negative would be, make that a plus, equals 0. So we have the square root of 16 plus 4 equals 0. And remember we said that the square root, we're going to be finding the principal square root. We're always looking for the non-negative. So the square root of 16 is 4. 4 plus 4 equals 0. I've kind of run out of room, but what I've ended up with is 8 equals 0. No, 8 does not equal 0. So that is not a solution. This x minus 4 is not a solution. Let's try x equals 2. The square root of 8 minus 2 times 2 minus 2 equals 0. The square root of 8 minus 4 minus 2 equals 0. Square root of 4 minus 2 equals 0. 2 minus 2 equals 0. And I've shown that 0 equals 0. That is a true statement. So I'm confident that 2 is my solution. But this negative 4 was not. What happened? Well, it's important to check radical equations because you may get a solution that does not satisfy the original equation. Because of this little trick we did step 2, we could get a solution that doesn't satisfy the original. It satisfies this equation, but not the original. These solutions are called extraneous. Extraneous solutions, and we do not include them in our answer. Okay, so let's do the steps again, just one last time to get a check on this. Step 1, isolate the radical. It's not by itself. What do I need to do? Yes, add 3 to both sides. So we have y plus 3 equals the square root of 2y plus 9. The next step is where we raise both sides to the power of the index. Again, the index is 2 because it's square root. So we're going to square both sides. And what happens here? Now, this is where I see people write y squared plus 9. Is that correct? Y squared plus 9? No, because what does that mean? That means y plus 3 times y plus 3 and FOIL it, right? So let's see, we'll see what we get. Square root of 2y plus 9 squared is, of course, 2y plus 9. And now we'll FOIL y squared. We'll get a 3y and another 3y for a total of 6. So see, we do not get y squared plus 9. Be very careful with that. That is the most common mistake next to not isolating the radical and not checking in these types of problems. Okay, so again we have a quadratic. I want this to be equal to 0, so I can either factor or use the quadratic formula. So I'll subtract 2y, and I'm going to subtract 9, and I get what? Y squared plus 4y and equals 0, right? The 9 cancels. So let's come up here. We've got y squared plus 4y equals 0. I'm going to factor a y out, y plus 4. So y equals 0 or y plus 4 equals 0 and y equals negative 4. And now we check. Let's check y equals 0. Back to the original. 0 equals the square root of 2 times 0 plus 9 minus 3. 0 equals the square root. Well, that would just be 9. And the principal square root of 9 is 3. And 0 equals 0. So we feel good about y equals 0. And it's not true that always one will be extraneous. Sometimes both of them are perfectly fine. So you do have to check. Okay. Negative 4 equals the square root of 2 times negative 4 plus 9 minus 3. Negative 4 equals the square root of negative 8 plus 9 minus 3. Negative 4 equals the square root of 1 minus 3. What's the square root of 1? Just 1. So negative 4 equals negative 2? No. So negative 4 was an extraneous solution. 0 is the only solution we got that actually works.